Hi everyone, today we will look another part of chapter 6 linear inequalities in two variables, that is solve problems involving systems of linear inequalities in two variables. So now you can refer your textbook at page 171. State three linear inequalities that define the shaded region in each of the following diagrams. So we look at A. So given here the dotted line for x plus y x plus y equal A. So you want to identify three linear equalities. So first we identify where is the region. Okay, the three straight line involved are x plus y equal to 8. Okay, this one. This one. This is one of the border of the region. Next is y equals to 0. This one. Another one is this one. So here, the shaded region from this dotted line is going down. So your equalities will be less. Here for y equals to 0 is going up. So it will be y greater equal 0. Equal because you have this continuous line. Then for x equals to 0, also going to the right. So should be greater equal 0. So the three linear equalities that satisfy the shaded region are x plus y less than 8, y greater equal 0, and x greater equal 0. Next we look part B. Okay, given the line. So first we look where is the region, the border of the region. Here there is y equal to -2. Then this one, y-axis is x equals to 0. Then this line. Okay, y plus 2x equal to -4. So we want to identify the shaded region is above. Okay, for y plus 2x equal to 0, the shaded region is above. So will be greater. Then the shaded region is below y equal to -2. Okay, y equals to -2. Below, so that's why it is y less than -2. It's a dotted line, don't put equal sign. Then for y-axis is on the left. So on the left, it is less equal 0. So the three linear inequalities that satisfy the shaded region are y plus 2x greater equal -4, y less than -2, and x less equal 0. Next, we look at example 13. You can refer your textbook at page 172. Write the three linear equalities that satisfy the shaded region in each diagram below. Okay, so we look part A. Okay, just now the linear equation is given, but now linear equation is not given, so you have to find the linear equation first. So first we look this the first line. Okay, I label with 1. Okay, what line is that? It passes to coordinate y equal to 5. Okay, this coordinate passes y equal to 5. So this line is y equal to 5. Okay, the straight line is parallel to the x-axis, thus y equal to 5. Okay, passes coordinate 5, y 5, that means is y equal to 5. Next is the number 2. Okay, 0, 0 to 5, 5. So what you must do, you have to use the concept y equal to mx plus c. So first you find the gradient. Okay, you take y2 minus y1. I hope you all still remember the formula to find the gradient of the line. Okay, y2 minus y1 over x2 minus x1. So you will get the gradient is 1. Okay, 5 minus 0. Okay, 5 minus 0. This is the coordinate. You can take another coordinate here, 0, 0. Then for x also 5 minus 0, so you get 1. So this line passes y-axis at y equals to 0. So the y-intercept is 0. So the line is y equals to x. Okay, you must substitute into y equal to mx plus c. Your m is 1, okay, x, c is 0. So that's why you get y equal to x. So then the next line, okay, equation 3, the straight line is the y-axis. Okay, this equation 3 here, okay, is a y-axis, means that is x equals to 0. So the three linear equalities that satisfy the region, okay, what you can look here, for this one, for number 1 is going down. Okay, that's why y less equal, okay, than 5. Then for the second part is going up. So that's why greater, y greater equal x. Then for y-axis here, x equals to 0 is going to the right. So x greater equal 0. Next, we look part B. Okay, you have 3 lines also. You can label it 1, 2, 3. If you look first line, okay, it passes to the coordinate 0, 2 and 4, 0. So what you must do, you have to find the gradient first. You find the gradient, okay, 2 minus 0, 0 minus 4, so you get negative 1 over 2. Then this line passes y-axis at y equals to 2. So the y-intercept is c equals to 2. So you substitute into y equal to mx plus c. M is negative half x plus 2. Next, same goes for the second line. Okay, passes 4, 0 and 0, negative 4. This coordinate. No? So you find the gradient first. You get 1. The y-intercept, okay, this line passes y-axis at negative 4. So the y-intercept is negative 4. So you use y equal to mx plus c. Y equal to mx, 1x minus 4. Next, the equation 3, y-axis is x equal to 0. So the 3 linear equalities that satisfy, okay, for the first line, it going down. So it becomes less equal because continuous line less equal, negative half plus 2. Then the second one, y greater. Okay, going up, y greater equal x minus 4. Then the next one, the third line is going to the right, so y greater equal 0. Sorry, x greater equal 0. This is the line x equal 0. So x greater equal 0. Next, we can do example 14. Madam Carol needs to select at most 20 pupils for a choir competition. The number of girls is at least twice the number of boys. Write two linear equalities other than x greater than 0 and y greater equal 0, which represents the conditions of the selection of the competitors. So you have from the question, you know there are two groups. One group is girls, another group is boys. So what you can do, you can let X represents number of girls and Y represents number of boys. So at most 20. That means cannot beyond 20. Okay, cannot be greater than 20. So when cannot be greater than 20, that means when we plus both, X plus Y must be less or equal 20. This is the first equalities. Then the number of girls is at least twice the number of boys. So girls is X, should be at least twice. That means at least greater or equal than 2 times of the boys. So X should be greater equal to Y. Or you want to write 2Y less equal X also can. Because you want to make Y the subject of the formula so that the region can be marked correctly. So you will get X greater equal to Y. So you change the subject from X to Y. Next, for part B, you already identify the equation. You find two coordinates, and then you draw the line. Okay, X plus Y equal to 20. Here they took the coordinate 0. When X equals to 0, Y is 20. And when X equals to 20, Y is 0. So you mark, then you plot. Then for the second equation, 2Y equal to X. Okay, you mark, you find the coordinate, then you mark, then you plot. So now we want to identify the region. So the first one, X plus Y less equal 20, less. Here, this part. Then this one, 2Y also less equal. So this part. Then should be greater than 0 lah. It must be in positive side. So this is the region. Okay, the number of girls and boys must be in positive. That's why it should be a positive region. Okay, next we look part C. From the graph, determine the minimum and maximum number of girls when the number of boys is 5. So here, number of boys is 5. So the minimum, okay, it cuts the region, okay, at minimum when X equals to 10, and it goes until when X equal to 15. So that is the answer. X equal to 10 girls is minimum and X equal to 15 girls is maximum. Next, the second part, determine whether the condition of the selection adhere to if 8 boys want to participate in the choir competition, justify your answer. Okay. So if 8 boys want to participate, okay, that means the Y equals to 8. So from the graph, Y equals to 8 is around here. Okay, this part here. Okay, when Y equals to 8, actually it doesn't satisfy the region, doesn't meet the region at all. So no, because the value of Y equals to 8 outside the shaded region. Okay. Next we look example 15. You can refer your textbook at page 174. The maximum number of passengers on a train in a theme park is 30. As a security measure, the required number of adults is always greater than or equal to the number of children. Write two linear equalities other than x greater equals 0 and y greater equals 0, which represent the given situation. So here you have two groups. One is adult and another one is children. So what you can do, you can take x as adult. here, okay, in this case, they took X as a children. Okay, you have to mention what is the variable stands for. So here X stands for the number of children and Y is adult. So I think I write above here, will be easy. Okay, X is children. And Y is adult. So here X plus Y less equal 0. Okay, why? Because the maximum number of passengers on a train in a theme park is 30. That means when you plus both children and adult, should be maximum should be 30. Cannot go beyond that. Cannot be greater than that. That's why X plus Y less equal 30. Next, as a security measure, the required adults is always greater. That means adults should be greater or equal to the number of children. So Y should be greater or equal than X. These are the two equalities. Then we have to draw and shade the region. So you want to draw, you find 2 points, any 2 points. Okay, you want to plot a straight line, you need 2 points. So X plus Y equal to 30. So you find any 2 points. Then for Y equals to X also, you find any 2 points. Then you draw the line Y equal to X and X plus Y equal to 30. Then after that, you shade the region. Okay, how you shade? Okay, for this one, X plus Y less than 30 is here, and Y should be greater, is the above part. So this is the region. Okay, you just shade. This is the region. Next, from the graph, determine the maximum number of children that is allowed to board the train. So maximum number of children. Okay, how you want to identify? Okay, this is the region. Okay, this is the maximum number of children. That means from 0 until the region ends in where? Okay. Okay, from 0, it ends here, from here. So it is 15. The maximum number of children is 15. Then, if there are 18 children, can all the children board the train at the same time? Justify your answer. So as we know lah, because the number of children is only 15. Okay, just now from the region, the maximum that we get is 15. So the value of X equals to 18 is outside the shaded region. So they cannot board the train. So I hope you all understand this subtopic. Thank you for watching.